Imagine a particle, a tiny speck of matter hurtling through space. This particle, like our planet Earth, spins on an axis. Helicity is a way physicists describe this spin in relation to the particle's direction. It's like determining if the Earth spins clockwise or counterclockwise as it orbits the Sun. In the simplest terms, helicity tells us whether the particle's spin is aligned with its direction of motion, right-handed, positive helicity, or against it, left-handed, negative helicity. For massless particles like photons, particles of light, helicity is fixed. For particles with mass like electrons, helicity can change depending on the observer's perspective. Helicity is a fundamental property of particles just like their charge and mass. It plays a crucial role in how particles interact with each other, particularly in the realm of nuclear physics. The study of helicity unveils fascinating secrets about the universe's most fundamental forces. Helicity is particularly important when we consider the weak force, one of the four fundamental forces of nature. The weak force is responsible for radioactive decay, a process where unstable atomic nuclei transform into more stable forms. A prime example is beta decay, where a neutron decays into a proton, an electron, and an antineutrino. The weak force dictates that the emitted electron will always have left-handed helicity, while the antineutrino will always have right-handed helicity. This inherent asymmetry in helicity is a hallmark of the weak force and demonstrates its violation of parity symmetry, a fundamental concept in physics. Helicity also plays a crucial role in our understanding of polarized beams, beams of particles where the spins are predominantly aligned in a specific direction. By controlling the helicity of these beams, physicists can probe the structure of matter and study the dynamics of particle interactions in exquisite detail. In the quantum world, particles are described by wave functions, mathematical expressions that encapsulate their properties, including helicity. Helicity states, specific wave functions corresponding to definite helicity values are essential tools for understanding particle interactions. For instance, in scattering experiments where physicists collide particles to study their interactions, helicity amplitudes, probabilities associated with specific helicity states, are crucial for interpreting the experimental results. These amplitudes reveal information about the forces at play and the internal structure of the particles involved. Helicity is also intimately connected to spin-orbit coupling, a phenomenon where a particle's spin interacts with its orbital angular momentum, influencing its energy levels and behavior. Understanding helicity is key to deciphering the complex interplay between spin and orbital motion in atomic and nuclear systems. Helicity is more than just a theoretical concept. It's an essential tool for experimental physicists. Modern particle accelerators like the Large Hadron Collider at CERN routinely use polarized beams to explore the fundamental building blocks of the universe. By carefully controlling and manipulating the helicity of particle beams, physicists can probe the structure of protons and neutrons, the constituents of atomic nuclei, with unprecedented precision. These experiments provide insights into the fundamental forces that govern the universe and the nature of matter itself. Helicity is also a key concept in the search for new physics beyond the Standard Model, the current framework describing fundamental particles and their interactions. Deviations from expected helicity patterns could point to the existence of new particles or forces yet to be discovered, revolutionizing our understanding of the cosmos. In conclusion, helicity, a seemingly simple concept describing a particle's spin, has profound implications for our understanding of the universe. From the heart of atoms to the vastness of particle accelerators, helicity is an indispensable tool for unraveling the mysteries of the quantum world and pushing the boundaries of human knowledge.